Jingle bells, numbers flow, make the hero stay. Adding, subtracting every day makes my brain work and play. Math is my favorite subject, all my favorite in class. Solving problems, feeling great, let's make this season last.
Hey guys, let's go over quiz number 5. January 25th, 2022, talking about polynomials, which is true of this function. Okay, the first thing is this thing called the leading coefficient. The leading coefficient is the one in front of the highest degree. In front of the highest degree. Now you'll notice something, they try to trick you here, and it tricked me, is that this polynomial is not written in descending order. Descending order is like the D is going down, and that kind of goes to another vocabulary word, is the word degree. So I'm going to write this one first, 2x to the 4th plus, because there's no subtraction, and then minus x plus 7. So the leading coefficient is this one here, so it's going to be a 2. So not this one and not that one. And then the word degree, the highest degree is here, the little number in the top right. That is the exponent, so that would be a 4. So then my answer would be A. A, that's B. Alright. Number 2, which of the following graphs has an odd degree? The easy is x to the 1st, right? That's a linear, looks like this. And then a positive means that those arrows stay the same. Okay, so I need an arrow in the bottom left down here. And the only one that has that is this graph and this graph. And then I need another arrow. Let's see, I did that in green. Let's do this one in yellow. I need one in here in the top right, an arrow on the top right. Okay, the only one that has that is this graph and this graph. So the only graph that is both an odd degree and has a leading positive coefficient is this one here. This graph here is your answer. Number 3, let's take a look at this graph. Mark all that is true of the graph given below. So first, we're going to talk about degrees. So we talked about an odd. The easiest odd is x to the 1st, and that looks like this. And then an even, the easiest even is the 2, right? We're talking about that number, right? That's odd. This is an even number. And so this one has the arrows in the same direction. So that's why this one is an even degree, the graph, because I have these arrows right here. See that? Okay, the next thing is the leading coefficient, which we talked in the last problem. And notice how this graph has my arrows pointing up. This would be a positive coefficient, and if I make it point down, this would be a negative x squared. So this graph has a negative coefficient because the arrows are now down, not up. So your answers are both A and D. Each expression a polynomial. So a couple of things here. Remember, the exponents should be whole numbers. So that means no negatives. That's really messy. Fractions or variables, like 2 to the x power. That's an example. or x to the 1/2, or x to the -3. Does that make sense? Okay. So here, this one looks good. This is a polynomial. Okay, you can have a fraction as the leading coefficient, so that's fine. That one's a polynomial. All right, let's go over question number 5. Determine which of the following graphs contain origin of symmetry, but not x or y axis symmetry. So symmetry, you know, if you graph these, let's just do a quick graph of this one. This is an odd degree, so I know it's going to look something like this. Algebraically. So we did it graphically, and now we're going to do it algebraically. How do you do it algebraically? For symmetry, this means sub -x for every x value. Oops, that says value. Okay, what does that mean? So for the first one, I'm going to put in negative. I should do this in light blue to stay consistent with my color system. Okay, so I'm going to put in, instead of x there in the parentheses, I'm putting in a -x. And that just means -x 5 times. All right, let's go ahead now and simplify this. Negative times a negative is a positive. Negative times a negative is a positive. X times x is x squared. And then don't forget you have this one left, -x. So if you multiply all of those, go back to the blue. Remember, when you're multiplying with the same base, so x, 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 you add the exponent. So 2 plus 2 plus a 1 is 5, and you have the leading coefficient that's negative. So the opposite of the original, right, if you did something like this, factor out the negative, this is the opposite. In my phrase, it's op x. That means it's going to be an odd symmetry. Okay? Let's go ahead and do that for the second one.
Use the coordinate plane to sketch a graph with given characteristics. If the graph is not possible to sketch, explain why. So here I have n behavior as I go towards the right. Remember, the x values are the x-axis. It's saying the f of x, or the y values, are going up. So as I go towards the right, it's going up. So that's my blue. The yellow here, as I go towards the left, it's going down. As I go towards the left, it's going down. A y-intercept at -2. So the y-axis, that's where it's intercepting. Let's do red. There are 3 x-intercepts. Okay, so you can place those anywhere you want. We might have to change those later, but I'm just gonna do something like this. And 2 relative extrema. So that's the same thing as 2 turning points. 2 turning points. Okay, so let's see if we can get 2 turning points, and if not, we might have to do some erasing. I'm going to go left to right. Okay, so I have 1 turning point and possibly that one. That's my second turning point. So I think we can get that one. That one works, right? All right, question number 8 tells you to circle the functions. Which one is the correct answer? After you circle it, then you have to describe both eliminating and choosing. Okay, let's do the first one. This graph here is an odd degree because x to the first looks like this, and my arrows are this way. This graph also has 2 turning points, 1, 2. So the turning points is equal to degree minus 1. So the turning points is 2. Then I know that my degree is a 3rd degree polynomial. Something you can also think about is your y-intercept is going to be a negative number. And my leading coefficient, LC, is going to be positive. I know that because my arrows are in the same position as this one. Okay, so let's go through each of these now. This one has a positive leading coefficient. That's good. Let's look at the degree. X times x times x gives us x to the 3rd. And then if you really wanted to know the y-intercept, you can multiply 7 times 1, which is 7. 7 times negative 5 is negative 35, negative 38. Okay, let's see if it matches. And I wrote A. Yes. That one matches because the graph has an odd degree. So that's an odd, and that's also an odd. And a positive leading coefficient, positive leading coefficient, positive leading coefficient. Okay? Let's try B. Okay, this is a negative leading coefficient. X times x times x is going to give me x to the 3rd. Let's do the y-intercept. Negative, that's negative 14, negative 14, positive, and minus negative. So that'll still be a positive y-intercept. So we have a odd degree, but a negative leading coefficient. So yes, for the purple, leading coefficient, no. And that's what I wrote. Positive. The graph has a positive, but we have a negative. And the last one. So this is a positive leading coefficient. We have x, 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 x. So I have here x to the 4th. This would be an even degree polynomial. 7 times 1 is 7, negative 35, and I would have a positive y-intercept. And so that's what I wrote for C. Graph has a degree 3, but our option is a 4th degree polynomial. This is how I awarded you points. 2 points gave you, you circled the correct answer, but no explanation. You got 3 points if you wrote all the characteristics. So that would be up here in green. All of these characteristics. And you had maybe 1 or 2 correct. I gave you 3.5 points if you didn't explain the other 2. So you circled A and gave me all the characteristics.
If you love my pretty much, let's begin to try it with me and you will get the score. Better, better, better score, and then try again with me. Let's begin again right now. Again.